Namaste. In this video, we shall learn about the assembly program to add two multi-byte numbers stored in the external memory location. So we are adding two numbers which are multi-byte, which are stored in the external memory location. So whatever would be the numbers, so I am taking an example of this. So this is number 1 and this is number 2. As it is mentioned, it is a multi-byte. So we have considered here an example. In each number, there are 1, 2, 3, 4 bytes. So this is my first number consisting of 4 bytes, which is one multi-byte number. This is another number which is consisting of 4 bytes. It is another multi-byte number. So as usual, whenever we add, we will be adding the first lower significant bytes. I'll be getting the results. Based on this carry, I'll be adding these two along with the carry. I'll be having a result. If there is a carry, I have to add here. I have to add these two numbers with the previous carry, store the result. Add these two numbers with the previous carry, store the result. And here is my final carry. So this is what exactly I have to do. So rather than taking the examples directly, let us consider these numbers, whatever may be the numbers are stored in the memory location like this. The first number ka least significant byte is stored in the memory location 9000. Next byte is stored in 9001. Next byte is stored in 9002. Next byte is stored in 9003. Similarly, second number ka lowest significant byte is stored in 9100. This is stored in 9101. This is stored in 9102. This is stored in 9103. So once after adding these numbers, let us consider the lowest significant byte of the number result is stored in 9200. Next is in 9201, 9202, 9203 and 9204. So this is what we have to do. So what we are doing here, the numbers are stored in the memory location 9000, 9101, 9002 and 9003. Here is my first number. Second number are stored in the memory location 9100, lower significant byte followed by that 101, 9102, 9103. Now we have to add the number in such a way that the data present in 9000 plus the data present in 9100 should be added and the result is stored in 9200. In the next step, the data present in 9001 should be added with the data present in 9101 with the previous carry, and I have to store the result in 9201. In the next step, the data present in 9002 plus the data present in 9102 should be added and the result should be stored in 9202 and so on. So whatever it is represented here is not the data, it's an address. There is certain data in these addresses. Whatever may be the data based on the user enters, we have to write a program in such a way that the data present in these memory locations will be added respectively and the results will be stored in this memory location. So as we know, in the assembly program of 8051, we have an instruction to add is ADD. As we have to add along with the carry here, we shall use ADDC, and compulsorily A should be the destination register, and this can be a register, direct address, indirect address or an immediate value. So what shall we do here? Whatever the data present in my first memory location, that is 9000, let us copy it into A. As I want the same A register for my next data to be taken, so we shall copy this to the register B, and the next data that has to be added, let us take it in the register A. Now we shall add these two, that is the data present in A plus the data present in B using the instruction ADDCA, B. Once after the addition is done, the result will be there in A and we shall try to store it in the respective result memory location, whatever it has been planned. So let us try to write the program of the same logic whatever we have discussed here. Before the beginning of the program, if we clearly observe all these addresses, higher byte of all the addresses are different, but the lower byte of these two are same. So what shall we do? As the lower byte is similar, let us store only the higher byte of the addresses in some register. Say 90 in one register, 91 in one register, 92 in one register. Because if I leave the higher bytes, see the lower bytes are the same. Here also, if I leave the higher bytes, the lower bytes are the same. Hence, we shall try to store this in some register while writing the program. To begin with, we shall try to begin writing the program with the instruction org00h. As the address initially we have considered is 9000, I'll copy the address 9000 into the DPTR. Now 90 into the register R0, 91 in the register R1, 92 in the register R2. What is 90 here? Higher byte of the initial address of the first number, higher byte of the initial address of the second number, higher byte of the initial address of the result. As each number is having 4 bytes, I am copying 04 into the register R3. Now, let us copy the value of the register R0 into DPH, that is 90 into DPH. So, DPTR is now 9000, that is it is pointing here. Whatever the data present here, let us copy it into A by using the instruction move X A, at DPTR. So DPTR is pointing to 9000. The data present in 9000 is being copied to A. What I want, A should be empty because for my next access. So let us copy the same into the register B. So now move B, A. Whatever the data which was present in A is now copied to B. Now what I have to do? The data present in 9100 should be copied to the register A. But the DPTR is pointing here. What should I do now? Instead of 90, I have to make the DPTR or DPH 91 so that the DPTR will be 9100. So what shall we do? Move DPH. Only DPH if I change, this will be retained the same. So move DPH, R1 because R1 is stored with 91. So DPTR is now 9100. The data present here, let's copy it into A. For which I have to write the instruction move X A, at DPTR. So one of my data which has to be added is there in the register B and another data is in the register A. Now both of this to be added using the instruction ADDC. So let us do that by using the instruction ADDC A, B. So where is the answer now? It's in accumulator. Where should I store it? In the address 9200. So already DPTR is pointing to 9100. I have to make it now point to 9200. What shall we do? Instead of 91 present in DPH, we shall make 92. So move DPH, R2 because 92 we have stored it in the register R0. So now DPTR is pointing to 9200. Let us copy the data present in 9200. Present in A to 9200. So what shall I do? At DPTR, A. So A is now copied to 9200. So the first byte we have added now and we have stored in the respective memory location. What we have to do? We have to do the same for the remaining 1, 2, 3 memory locations. For which, what shall we do? Let us repeat this how many times? 4 more times. So I'll use the instruction djnz R3 because the number of bytes we have stored it in the R3, loop. So R3 is having 04 until it becomes 00, it reaches back to loop and I have to write the loop here. So it will be repeated until this 4 bytes is completed. Once after the register R3 becomes 0, it comes out of the loop. I have to now check if the carry is there while adding the last 2 numbers. If the carry is there, I have to store it in the memory location 9204. If the carry is there, I have to check that using the instruction JNC. So let me write JNC loop 1. If carry is not there, we shall go to loop 1. If carry is there, we shall try to move the same into the register A. That is, if carry is not there, we are jumping to loop 1. If carry is there, we are moving 0, 1 to A because maximum carry that can be generated is 0, 1 only. And I have to store it in this memory location. Hence, 0, 1 is being copied to A and the same is now has to be copied to the next memory location for which we are writing move X at dptr comma a. So if carry is there, that will be there in the next memory location, that is 9204, else I have to end the program. If the carry is not there, I have to end the program, but end instruction cannot be written here, for which I have to write some dummy instructions. So that sjmp loop 1 let me write, so that it will be executing the same instruction until you stop running the program, and then we shall end the program. So once after this instructions are written and executed, where we have to check the result in 9200, 201, 202, 203 and 204. Keep always in mind the lower significant byte are in these locations and the higher significant bytes are in these locations. So as a user or a programmer, whenever we have to enter the number of a given number, we have to enter it carefully such that the lower significant bytes are entered in this memory location.